table, graph, and equation. And I can identify the constant of proportionality from a graph, table, and equation. So we've already done this from a table and an equation. Today we're going to be working on is from graphs. Okay. So anytime we have an equation that has a y and an x, so like when we have y equals kx, if we know everything else besides the x and the y, we can always graph that relationship. So let's say we have y equals 3x. We can always graph that on an xy plane. And when it comes to a proportional relationship, the graph of a proportional relationship is always a straight line that passes through the origin. Remember that the origin is the middle point, or 0, 0 on a graph. Okay, 0, 0. So, if we take a look at this, 0, 0, this line right here it goes through 0, 0. However, it's not a straight line, so it is not proportional. Okay. Here, this line goes through the origin and it is a straight line. So therefore, this is proportional. This one is proportional. Or shows a proportional relationship. This last one over here is a straight line, but does not go through the origin. Okay, does not go through 0, 0. So therefore, it is not a proportional relationship. So therefore, it is the middle one because it is a line that goes straight and goes through the origin. Okay. So if you take a look at this right here, you can see that the constant of proportionality for this is going to be 2. Okay. And the reason for that is we can see 2 distinct points right here, or really 3 distinct points. 1, 2, 3. And if we were to take those points and put them in a table, an XY table. So this is our X and this is our Y. We would start off with what we already know is going to be part of every single proportional relationship, which is 0, 0. Then we have 5, 10, and we also have 10, 20. And you see that right here, 10, 20, 5, 10, 0, 0. Remember that the X value always goes first inside a coordinate point. Okay. And so here, remember that K is always Y over X. And so if we do 10 divided by 5 and if we do 20 divided by 10, both of those get us 2. So the equation for this one is Y equals 2X, with the constant of proportionality being 2. So we can do that with any point on a graph, and that is a graph of a proportional equation, and find out what K is by taking any point on there, either 5, 10 or 10, 20, and using that to find out what K is using our equation for a constant of proportionality. So let's take a look at this one. The cost of renting a video game from Games Incorporated is shown in the table. Determine whether the cost is proportional to the number of games rented by graphing on a coordinate plane. Explain the reasoning. So cost, it depends on the number of games rented. So we control how many games we rent, and the cost is Y. Here we have 1, 3, so let's graph that point real quick. 2, 5, 3, 7, 4, 9. Okay, and so if we were to connect all those points, we would find that it would make a straight line, but we can see that that line does not go through 0, 0. So therefore, this is not a proportional relationship. It's not a proportional relationship because even though it's a straight line, it does not go through the origin. Okay, because 0 games would seem to cost us $1 if this were to continue in the same way. So if the pattern would continue, that is. Let's take a look at the next one. The slowest mammal on the earth is a tree sloth. It moves at a rate of 6 feet per minute. Determine whether the number of feet the sloth moves is proportional to the number of minutes it moves by graphing on the coordinate plane. Explain your reasoning. So we're going to graph these points that are given right here. Again, time is almost always our x, because we control how long we do something, and distance depends on how long we're doing something. So we got 0, 0, 1, 6, 2, 12, 3, 18, 4, 24, and that kind of looks like a straight line, and if we were to connect all of those points, it would look like that. Okay. Well, I can draw that a little bit better, but you guys get the point. It would look like that. So, therefore, it is a proportional relationship because the graph of all the connected points, once connected, result in a straight line that goes through the origin. Okay. So a straight line, what a straight line really represents is that it goes up the same amount each time. So here we go, over 1, up 6. If we go for another minute, it's over 1, up 6. If we go another 6 feet, over 1, up 6, over 1, up 6. So we go 6 feet each minute. That's why it's going to be a straight line. Over here, this is a straight line because after you buy the first one, it's going up $2 each time you buy a new game. Okay, but the issue is, again, even though it's going up $2 per each game, we don't start off at $0 when you buy 0 games. So therefore, this is not a proportional relationship. We just talked about this. Identifying the constant proportionality or unit rate given a graph, you can find the constant proportionality by finding the ratio y over x for any point on the graph. Okay. So let's try to identify the constant of proportionality in each graph below and write the equation. So here we got 3 points we could use. We can use any of these points. We can use 6 divided by 3 and 4 divided by 2 or 2 over divided by 1, because again, remember that the second number is the y and the first number is the x. Okay. So here our equation is going to be y equals 2x. And notice how you can always find the constant proportionality right here for when x equals 1. We can just look at what y is, because remember that the constant proportionality is the same thing as unit rate per 1. Okay, so that's why when y over x, when x is 1, we can find the unit rate by just looking at the y, because it's per 1. X is 1, so we just look at what the y is for that. Over here, it's a little bit harder to tell because, well, this is not a given defined point that we know. But we can look at the other points to determine it, and we can see that this point right here is 2, 1. We can see the next point is 4, 2. The next point after that is 6, 3. And the next point after that is 8, 4. We could do one more if we wanted to, 10, 5. And we can use any of these points to determine what the constant proportionality is. So let's just use 3 and 6. Why not? So 3 over 6, so it simplifies to 1/2. So our constant proportionality is 1/2, okay? Because k equals y over x. And we check the y divided by the x. And so our equation is going to be y equals 1/2 x. And what that means in here is that for every hour, we go half a mile each time. And you can kind of see that this is half a mile each time, right? And over here, what this means is one soda costs $2. Each soda costs $2. So every proportional or direct variation relationship must be written in the form of y equals kx, which the following is not a proportional and direct variation equation. So only one of these is not. And go ahead and try this one out on your own. What you should have found is that C right here is not, okay? Because all of these other ones come in the form of y equals kx. The issue here is that we have this plus 8 in C. It doesn't matter if the k value is negative. It can be negative. I haven't shown you any of those before, but it can be, okay? And that's perfectly fine. Here it says, below is a graph that shows the distance traveled by the 2 runners in a race. Which runner is faster and how do you know? Go ahead and try this one out on your own. What you should have found is that runner A is going faster because they travel more miles every hour. That is, runner A's graph is going up faster than runner B. So we can see that runner A every single hour is covering more distance than runner B. What is the speed of both runners in miles per hour? Go ahead and try this one out on your own. What you should have found is that runner A is going 8 miles per hour, while runner B is going 6 miles per hour. And we can tell that because we can take any point on this A and find the unit rate. But we can also just take a look at right here where this is 1, 8, and see that, okay, since our x value is 1, our y value is 8, so 8 over 1 is going to be our unit rate, so 8 miles per hour for runner A. And then for runner B, we can do the same thing and see that they only go 6 miles in the first hour. So 6 over 1, so therefore 6 miles per hour. The next question says, how far will runner A have gone after 3, that should say hours. Change that to hours. How far will runner A have gone after 3 hours of running? What you should have found is that they should have gone 24 miles because it's 8 miles per hour, and so we multiply that by 3, since it goes 3 miles every hour, that gets us 24 miles. What you could have also done, though, however, is taken a look at the graph and seen at 3 hours, so if you go all the way up, where the runner A's line crosses, and go all the way to the left, you can see that is also 24 miles. Okay, 24 miles right here. So therefore, they went 24 miles. Either way works. But you can see how using a graph can show us those relationships pretty quickly.